So this little video is about how we can pass arguments into functions in Python. So we're going to pass it, and there's two ways of doing this, which is by value and by reference. These two ways are conventions, so sort of method one, should we say, and method two here. Are the two ways, and generally this is how it's done in all programming. Python's kind of like got a slightly different but analogous approach, which is to, instead of and what this means is when you pass by values, you're kind of like passing the actual value of the item. And when you're passing by reference, you're like passing a pointer to the reference of the items. You're kind of like passing a piece of memory. So if you change the value, you've actually changed the value everywhere in the reference. Whereas when you pass by value, if you've changed by value, you're changing it locally. And this is also kind of like to do with the local versus global scope. But anyway, I'll move into a function and we'll kind of like see what that means. So we'll just define a function in Python. And we could have defined a function in another language, but so we're defining it Python for that. And we'll pass in, we'll create one parameter which will be able to accept arguments, and we'll say that this will take integers. So we'll type in for an integer. And what we'll actually do next is something like, we'll just say a equals 10. And then we'll call our function just like that, and we'll pass in our variable of a, and then we will do something like this, which is print a. And I was testing a lot of stuff down below, so I'll just hit clear over here, because all of our results, when I press the F5 key, I won't press the run key over here. I will press the F5 key, so it's a keyboard shortcut. And when I do press that, our results will come down in here. So like when we've got the print the value of a. And I will start labeling things as well. But just for now, to make sure that our function is running, or our code is running without any problems, we can hit F5 and we see that a equals 10. Well, if a equals 10, we haven't actually changed any values of a or done anything with it. We did call our function. We passed a into 10 into a, the value of 10 to the variable a inside of our function. So the argument was 10, and it's been passed into the parameter. But nothing happened because we didn't do anything in the function. So anyway, when we came up, we were only expecting to get 10 as a result. So now let's just set a equals 20. And you know, the first question is what's going to come out. Now I know just from the color of the type hinter or the linter that this is grayed out, so kind of like a, nothing has taken effect. A is local inside of the function. And if we run our piece of code again, we see that we still get the value of 10. And in order to kind of like prove this to ourselves, what we can do is we can select print inside the function, and this will be our value of a and a. So we are going to print out our value inside of the function. And now we will do the same thing, copy that over there, and this is for, instead of inside, it is now outside the function. And when we run our little piece of code now, we see that we get two different values for a, and that is because an integer is a immutable data type, which means that it's taken two different positions in memory, and we can actually identify the two different positions in memory as well. And the way that we can do that, because it's a nice little function which I did go through quite a long time ago, which is next we'll do memory location, or address, well, I'll call it location, inside function of our variable a, just like that. And it's the ID function a, and if I just hover over it, I wonder if I can hover over it now and see what it pulls up. But it says here, return the identity of an object. This is guaranteed to be unique among simultaneously existing objects. CPython uses the object's memory address. It's effectively this number, this unique reference number, is a reference to the memory address, and if they share the same address, they will have the same number, and if they have different addresses, then they will have different numbers. So, and this is just like to prove to ourselves. Just close. I opened up a file by accident there. Right, I was just UT, yeah, I had to type it there, right, outside of the function. So let's just run this now, F5. And what we see is, so we've got this 20 over here down below, and then we've got this 10 over here down below, and they're as expected as they were before. And we've now validated to ourselves that this type is immutable, so it's changed its memory location. This variable a is completely different in memory space where it exists on the computer to this variable a over here. They've literally got two different memory addresses, and we can see that. Now, I'm going to do all of the exact same stuff again. So I'll do a print. I'm just going to separate everything like that. And I'm going to copy this entire block of code. So we'll keep our first piece of code, and it will be separated by like dashes this time. But what we're going to do is we're going to change. I might actually even put a little comment here. We've used a immutable data type. And I actually Googled this before as well, sort of like to pop it up and have a look. You know, I've literally pulled up on Google mutable and immutable in Python. There's a whole ton of them. You can go down and pick your, pick your version of what you wanted. But this one did pop up, and kind of what is mutable? Mutable is when something is changeable. And what is immutable? It's when it's not possible, so you're sort of like assigning it to a new address. And then it goes through what are mutable things, and they are the things that are mutable, that are changeable, are our list-like or our collection type of objects. So lists, sets, and dictionaries. Although you might argue that a tuple is a collection type of object as well, so it's not completely a collection type, but things that consist of bunches of items, whereas our immutable types are typically our numbers: rational, irrational numbers, floating point numbers, decimals, complex numbers, booleans, which are either trues or falses. Strings are immutable, tuples, frozen sets. So we won't go into like the extra bits, but generally speaking, things like integers or booleans or strings, they're immutable. So we're literally changing their memory location, and the mutable types we're not changing their memory location. And I'll copy this line over here, because really over there we have got immutable, and so Python's equivalent in a way is this is kind of like implicit really, is immutable, because they are by value, they're literally going to change the memory address. And then mutable, which is exactly the equivalent to by reference, because they are going to change. They literally they don't change. They change their values, but they don't change the memory address. The address stays the same, so is values inside it. So we'll see this when we run through an example. It will become a little bit clearer. So I'm going to literally copy all of this code. and paste it straight down below, and I'll start doing the modifications. First of all, we're going to use mutable data types, and I'm going to say immutable here is the equivalent to the by value that we're used to, and that's typical, by the way, and it's typical in Python. And then this is the by reference. So here we're going to hint that this time it's a list, and instead of using A, I'm going to use B, and that means I'd have to change all occurrences of A's to B's just to make sure, and that's just for the purpose of not confusing anything. So I'm just going to change them all here, but I will also have to change if I just go through everything, got to change all of these things in the strings as well, otherwise we'll have confusion when we've read it, because I did a practice one before and I got it all wrong. Got to be very careful with this. Here we go. So I've changed our function now, it's calling B. It's just for the purpose of not being ambiguous. We could have used A's, but it's just clearer so that we can see both sort of side by side with each other, or on top of each other down in the running of the code afterwards. But B now is no longer just an integer, it's now a list. So a list looks like this. It's now one of our mutable data types. I could have done this, by the way, with a dictionary. It's just a bit quicker and faster to do with a list, because we don't have to put key value pairs in, only have to put in values for a list. So it might be 10, 20, and 30, something like that. And then here we're going to do nothing at this point in time. And we're still going to run our function on B, so nothing's changed there, and we're going to print outside of the function B and so forth. And let's just have a look. So, and again, this was equivalent to when we did our first example at the top here with A, and we didn't put anything in. So here we've put nothing in for B, nothing's actually happening, and in fact I might even comment these out for now, control/the comment, just to make sure that B is nowhere. So B is kind of we can see that B is actually grayed out. So when we run our code, just to check that it works, what we're getting now is all of the stuff we had before for A, and then under this dashed line is everything for B, which is for our mutable data types. And the first thing that we see is that outside of the function, B is 10, 20, and 30. So just kind of like as expected, because that was created on line number 32. And then we printed that out on line number 35. And we didn't make any adjustments to B, although we ran it in function, we see it's grayed out. So the first thing that I'm going to do is b.append, and we're going to add on one extra item to that, so something like 40. Now I'm going to run this code again, F5, and we'll sort of focus on the bottom half of it, but I think we can already see, and if I hover over it, we can see outside of the function here we had 10, 20, and 30. But now outside of our functions become 10, 20, 30, and 40. So unlike in our A example, where changing its value didn't have an effect outside of the function, here doing append on B actually had an effect on our function, on our variable B here. And this is because it's passed by reference. That's the point about these mutable data types. They're not identically, but they're analogous to being passed by reference. A reference being passed, and we've changed that object by its reference. So, and I guess in order to prove that point, we can print. We'll do print inside the function B, and then we'll print its memory location as well. So I'm going to run this piece of code again for a second time, and what we notice is the inside the function over here, takes exactly the same values as the outside of the function. But even more importantly, or not more importantly, but just highlighting that point, we see that this memory location, this reference, this ID number, is actually identical for them. They're pointing to the same part of the memory, which is why they are the same value. Now, that's quite interesting, but I wanted to throw something else in that was a little bit even, I would say, more interesting, which is that if I do now b equals 10, or we'll do b equals 1, 2, and 3 this time, so something like this. And we're going to now do print inside the function b for a second time. So we're printing b inside the function twice. And actually, I might as well just do this. I might as well just copy this and paste it over here. We're also going to print its memory location. So if I hit F5 to run that, we're going to get two things that run inside of the function. But what we've actually seen happen now is this. We've got two different values for b inside of the function. We've got the 10, 20, 30, 40 from our append over here. And I'm going to get my little pen out now, I think. This b.append here, and this whole block over here managed to make its way all the way down to this little block over here. Excuse my poor writing, but that's what it's done. And I changed the color of the pen to like a blue. And our second piece of memory, our second running of it, so our 1, 2, and 3, and I think we know where we're going on this, manages to make its way over here. So like point that one to this. And finally, the outside of the function, which is our, I need to make sure that I didn't quite get this right. I didn't quite get my drawings right on that one. The blue bit was here. Let's just, if I can get the rubber and remove that one. Yep, there we go. So that's a bit better. And then finally, the outside of the function, and let's just like get a green there. This outside of the function over here, I'll come down the other side, sort of like made its way over here. There's the outside of the function. And what we can see is that the memory location outside of the function, so I wonder if this will, I don't know if this will do highlighting or drive. Yeah, it does do highlighting. This memory location here is exactly identical to this memory location over here, which meant that this b over here in the this b over here was exactly the same as this b over here, which meant that this b.append was exactly equal to this b over here. So they were pointing to the same thing. And what's actually happened, and I'll do one extra part of this. Let me just I wonder if I can clear. Yeah, it clears everything. That's good. Okay. The interesting part of this is that if I was to do just on our function now, another b.append, just like that, and I thought I was going to put in a 50, like, which b is now being appended? This b, because it was immutable, because it was mutable and it's passed by reference, was changing the b outside of the function. It's passed by reference, it's passing that memory location. Whereas this b is a newly created, so this list here is a newly created list that is created in a separate memory space. So the question is where is this list, this append, what's it going to operate on? Is it going to operate on our original list, or is it going to operate on our newly created list? And we'll see what actually happens anyway. I could also just do that part, but let's just take the print part of it to start with over here and paste it over here and hit F5 just to run our code. And we can see now, I think I printed it, yeah, there we go, we've got the inside of the function. And I think this should be logical, although you could argue maybe it's not logical. Python does operate in a very sequential way. Because this B now has been created, we've almost like lost our reference to this one, and now all of the B's that we're talking about afterwards are referring to this new value, so it's inside of the function. And we can actually prove that to ourselves, but we can already see that because it's already the 1, 2, 3, 50, so it looks like it's referring to this, but we can actually see that by passing in the inside the function of B, just like not that one, passing in our memory location just to show that it's the same memory location. So I'm just going to take this block of code and pass that over here and run, and we are going to see that this memory location, let's just really color them maybe or circle them with there, that these two memory locations, which are both inside of the function, are identical to each other, and these two memory locations, which are outside of the function, are identical to each other. When I say outside of the function, this append here and this variable initially is passed by reference. So these are by reference because they are mutable, and it only changed at this point over here where we created effectively a new assignment to the variable b inside of our function. So, and that's why these two inside of the function are now identical, and any b's after this point, so I could have kept on doing more appends or changes to it, will be the same value. And I think we could even extend that slightly, which is that let's just do a final b, but we're not going to do an append, but we'll do a b equals 1000, 2000 and 3000. Just something like that. We've created a new list, we've assigned a new list to b. But what we'll actually do is we can print it as well just to see what its values, but we know we're going to get 1000, 2000, 3000. But if we were to look at our memory location inside of the function, because that's what we care about, has it changed yet again because we've assigned it a completely new value? So let's just have a look at that. F5 to run it, and our inside of the functions are actually these three memory locations here. They've all run inside of the function, but again, and this is kind of like the point in highlighting, is that this one here has now changed its location because we've assigned a new b here, just as this one here had changed its memory location from here, and just like, or equivalently, I wonder if I can scroll, I don't know if I can scroll now because I've got this thing on, but this value here was, and this is the one that's passed by reference, which made its way, remember, up into here and over here. I'll put little dots where it was because we didn't actually change its memory. Its memory location was created down here, but this is a blue thing. So we can literally sequentially change it, and we're changing the memory locations, and we see that because this one here, if I put the blue line, or I shouldn't have used blue there, it wasn't blue. Get rid of that. If I use the correct lineage, this one here is yellow. That refers to the yellow line above over here. And these two are the red ones over here. So we've already changed our type and again, finally, just to highlight or drum the point in, this is what was created originally outside of the function, and this was what was passed in. This is our mutable type, which is passed in by a reference. So this was the reference over here. It's not the best of writing, because I don't think but this is actually the reference to that one, which is why it managed to make its way in. And any changes that happened here were changing the function outside until we assigned it effectively, and then we reassigned it again with the yellow, and we could keep doing reassignments. So that's just generally how mutable types works, and they also give us a way of passing values by reference, and that's quite an important thing computationally. This is not a Python thing just on its own. This is an all coding language thing. Sometimes you want to pass by value very specifically because you, or for the most part actually, you normally want to pass by value because you sort of want to work on the values that you've got. But sometimes you're sort of working on something that's got some sort of central repository or something like that, a hash table or something that you're keeping, that you're operating on, and you're making changes on it. It's sort of more like a global object, and those things you're passing by reference because the function is operating on something outside of it, and the way of getting it to do that is, or one very, very convenient way of getting it to do that is passing by reference, and Python's version of passing by reference is this mutable data type. So that's kind of like it. It's a bit of a long-winded explanation, but we sort of needed that long-winded explanation. If anyone's got any comments or thoughts on that, they're more than welcome to leave it in the comment section down below. And I never really ask for likes and follows and so forth, but it'd be very kind if you could like and follow. If you do like the video, if you do find it useful, definitely like and follow. But it also gives me good feedback. I do a lot of these sort of for myself, but I know that it helps others, and I watch other people's code quite a bit as well. It's very useful, especially something like this, where it's an extremely powerful tool to have, especially when you've got the understanding that you can pass variables, or you can pass arguments into functions in two different ways, by referencing and by values. So that's it. I'll leave the video here, and thank you.